What if the future of medicine could be printed? Imagine prosthetic limbs that can be produced in just a few hours at a fraction of the cost, and perfectly tailored to each individual. In today's presentation, we'll explore the technological advancements in 3D printed prosthetics, the societal benefits they bring, and ethical concerns surrounding the rapidly evolving field. Prosthetic limbs are artificial devices that replace missing body parts, typically lost due to an injury or amputation. Historically, prosthetic limbs have provided individuals with a means to regain mobility and independence, but the process of manufacturing these devices has been time-consuming, costly, and often limited in terms of customization. Medical 3D printing is changing that. This technology allows for the creation of physical replicas of body parts using computer-driven processes to layer materials like plastic or metal. 3D printed prosthetic limbs have several advantages over traditional ones. They can be tailored to fit each person's body, resulting in better comfort and functionality. Additionally, they are significantly more affordable. This lower cost makes it easier for people, especially in developing countries, to access the prosthetics they need. The process begins with 3D scanning, which uses lasers or structured light to capture precise measurements of a patient's limb. This data is then used to create a digital model that ensures a custom fit tailored exactly to the individual's body. 3D scanning is quick and highly accurate, which is critical for a comfortable and functional prosthetic.
3D prosthetic allowed user-driven customizations for a more precise parametric tailoring of the limb, which help increase comfort and functionality personalized to the user, which also includes change of colors or any artistic color choice based on the user. It also allowed a significant increase in cost and time efficiency, where one piece of traditional handmade prosthetic could have cost $2,000 to $7,000 for 14 to 15 hour worth of works, compared to 3D prosthetic for $155 with 2 hour worth of work. It's also allowed a share cloud data of the 3D design, which help expand the market and growing a maker community. This network can help facilitate the improvement of the model functionalities and robustness based on the end user feedback. With the use of open source data for prosthetic limbs, consent and privacy protection is extremely important, and there has been a rising concern for the prosthetic limb fabrication by people who are not certified nor subject to the regulations due to the lack of the regulations and education standard as well. Also, although the technology seems to be easily accessible with its low cost of production, however, the setup cost for manufacturing and repairing 3D prosthetic limb is still considered to be too high, all of which lower its availability within rural, low, or middle income countries. However, on the positive end, it helped lower stigma towards prosthetic user, especially in children.
Traditional prosthetics can cost up to $1.8 million over the lifetime of the patient. This cost alone indicates the need for a cheaper alternative. With 3D printed limbs, the comparative costs are significantly less than that of traditional prosthetics, with it costing as little as $50 per limb. But questions as to their durability and relative safety still remain. Most 3D printed prosthetics are made from plastics like PLA and photopolymers that can degrade when exposed to high temperatures or UV light. This raises safety concerns, as many devices may not last as long as traditional prosthetics. Due to these issues, most 3D printed prosthetics are not covered by insurance. Regulation plays a crucial role in balancing innovation and safety in Australia. The Therapeutic Goods Administration oversees medical devices, including 3D printed prosthetics. New regulations set to take effect will increase scrutiny over 3D printed devices, ensuring they meet higher safety and quality standards. These new standards will mean that many 3D printed prostheses that are made on a commercial scale will no longer be exempt from regulatory requirements and will now be required to be registered with the Australian Register of Therapeutic Goods. These regulations aim to increase safety of the devices while also fostering innovation in a more responsible manner.
The future of 3D printed prosthetics is incredibly promising. Advances in materials such as bioengineered tissues and smart materials are pushing the boundaries of what prosthetic limbs can do. Researchers are working on prosthetics that mimic human muscle, providing a more natural movement and response to user inputs. The future for personalized medicine is also evolving. 3D printing allows us to create prosthetics tailored specifically to an individual's anatomy and needs. This is particularly important for children who require adaptable devices that grow with them, and for athletes who need high-performance, durable limbs to maximize their capabilities. Finally, 3D printing holds immense potential for global distribution. In developing countries where traditional prosthetics are often inaccessible, 3D printing can create affordable, custom-fit limbs in just days, transforming lives on a mass scale. To conclude, 3D printed prosthetics offer a breakthrough in the field of medical devices, with unmatched possibilities for customization, affordability, and global accessibility. However, ethical and societal challenges, along with regulatory concerns, must be addressed to ensure this technology continues to improve life safely and sustainability. The future of 3D printed prosthetics is bright, and we are excited to see where these innovations will take us next.